Got your Applitools swag. I've got no Applitools swag. I'm jealous.
I have a decade worth of swag with me. So
oh, you really?
I have all the versions, everything that was ever out.
All right. Cool.
So it's a funny story, but the first t-shirts we got, there was a visual bug in them. So it was the wrong font. So we got like thousands of t-shirts that we couldn't use. It was really not what we ordered. So we just had boxes of t-shirts we couldn't use, and we just gave them away to everyone we could, like family and friends. So there are like thousands of people in Tel Aviv walking around with visually perfect Applitools shirts, and they're not. And we just spot them on the street. It's like
that's fantastic.
Yeah.
Right, people are starting to join anyway. Welcome to you attendees. So
yeah.
And we're actually recording already, so apparently it's really started to record already. The genius of Zoom.
Yeah.
So we're going to put our shades on now.
Yeah, that's the time. Let's put
it. Wait, here we go. See, mine are quite futuristic, you see, they're kind of, you know.
Yeah,
I know yours are. Yours look like an Arnold Schwarzenegger, kind of like Terminator ones.
You know, Back to the Future for me.
That's definitely on topic.
Yeah.
I'll have to put these up a bit, so I can't see where I'm going.
Yeah.
You see that? Can you see that message I've sent out? Yeah.
Yeah.
So I'm going to go for double. I'm going to go for double. You see. Yeah. So for people that are just joining, so we're gonna start in a couple of minutes. And if you've got any questions for Adam that we can pick up at the not the AMA session, but the AAA session, ask Adam anything. Then please put them at the bottom of the screen, and we can pick that up as we go through.
It works for Andrew as well, by the way.
Oh, that's right. It does, doesn't it? That's even better. I should have changed my name for the next session.
Should have started. Yeah.
That's cool. So what we can do actually during this session as well is we can allow people to talk and ask their questions, and we can actually promote them to be panelists as well. So we can bring them up on stage as part of the session, which should be really good as well. So yeah, if you want to come up on stage later on and ask your question directly of Adam or myself, yeah, that's the two difficult questions for me. I think that's for Adam. Then obviously that's something we can do in this webinar as well, which is cool. Okay, we'll just wait one more minute and then we'll get going. So I know that the actual weather in obviously in London is a bit different to Tel Aviv. Is that a correct assessment?
Actually, it's pretty nice outside today. It's not as cold as the Netherlands, and it was even there was more rain there, constant drizzle. So it's pretty nice. But in Tel Aviv, you know, it's always the sun is almost always out, even in winter. Yeah, it's not that cold there. Yeah. I have been spending a lot of the winter skiing though, so I've been much.
Yeah, I heard about that. Actually, I heard about that. Yeah. So you're permanently on a snow mountain somewhere. Yeah.
Yeah.
Daredevil.
As much as I can.
Okay, we'll kick off then.
Okay.
So welcome everybody to today's London TAD. This is the next event for the London TAD community. That's London Test Automation in DevOps. We've been running the actual community for quite a few years. My good friend Shashi Jagtap, who founded the group originally many moons ago. It used to be the London Selenium group, and then it morphed into the London TAD. And we run some physical in-person events. We've run obviously lots of online events, especially since the pandemic a few years ago. And so 2023, new year. So we were discussing recently with a number of people who were going to come on to the community during 2023. And Adam mentioned that he was going to be in London. So what would we do? But we couldn't turn down the opportunity to speak to the co-founder and CTO. So welcome, Adam Carmi. How are you?
Very good, very good. Happy to be here.
And obviously, I feel a bit left out because I haven't got an Applitools t-shirt on, but I'm sure everybody can get one after this event. So yeah,
yes, so anyone that wants a t-shirt is welcome to ask Andrew for it, and maybe
that's cool. Yeah,
at least whoever asks the most questions will get a t-shirt.
Okay, we got a prize. We got a prize then. Yeah, okay, signed by Adam. Yeah, so yeah, the oh, you see, oh, right, okay. So yeah, we thought we'd try and put a bit of fun into this episode because and this community event because obviously the whole thing is that the future's bright. So you know, one of the things obviously with Adam's background, and we'll cover that in a second, is that he's obviously a very experienced practitioner and been working in this industry for quite a long time. So I think it's a great opportunity for us to understand more about, you know, not only where he's come from and what triggered him putting together creating some of the really excellent technologies built over the last 10 years, but also to, I suppose, share his view on the future. So, I mean, first I want to say welcome to Silicon Roundabout. Yeah, because you know in London it's called Silicon Roundabout near Old Street. We're obviously running this virtually. But I know you're not far away from Silicon Roundabout where you are now. But obviously, the key thing in Tel Aviv you see in Israel, it's Silicon Beach, isn't it? Is that what they call it?
Yeah, exactly. There's also a name for in Salt Lake City. They call it the Silicon Slopes. So,
oh, really? Okay.
Yes, yeah. So every tech center has its own variation on Silicon Valley, right? So
that's cool. I didn't know that actually. So that's a new one for me. Yeah. So welcome to Silicon Roundabout or near Silicon Roundabout. And also, I suppose the other celebration I was going to say was, I think it's a special year, 2023. Is that right for the business that you co-founded?
Yeah, actually, we started Applitools exactly 10 years ago. It was the beginning of 2013. Yeah, so 10 years have passed.
A major milestone. Yeah, but you see, Adam, you keep looking younger every time I see you. You look even more younger. You see, so it's like
thank you. I promise to continue to. It's like Benjamin Button, right? So
yes, exactly.
Like that, yeah.
So I suppose to help people who obviously don't know a lot about Applitools, don't know a lot about yourself. I mean, could you give us a bit of a little bio and little introduction about, you know, what's your origin story, and what happened to trigger you to create this amazing business that you're working on, an amazing topic that you talk about.
Yeah, sure. So so a little bit about my background first. So I'm the CTO and co-founder of Applitools. Basically, Applitools invented visual testing, visual test automation as we know it today. I spent many years speaking at conferences, educating the market about visual testing, promoting the many open source tools that came up like mushrooms after the rain, following our evangelism of the subject, of the topic, of this new category of testing. And we're a company that constantly focused on innovation, not doing the same things that everyone was doing before. So coming up with a new way of testing based on computer vision, then coming up with a new way of executing your test across devices and browsers with our ultra fast grid, and soon to reinvent test automation with autonomous testing. So we'll cover all of that in more depth, I'm sure, later on. But before Applitools, I ran R&D organizations in various companies. I worked as an architect and as a researcher in IBM Research, Microsoft Research, and in Intel. Basically, I'm a software engineer at heart. I've been writing code since I was 10 years old.
10? Really? Oh, wow.
Yeah, not first computer, but I started to write software on BASIC, on an Atari.
I was going to ask you, what was your first computer? An Atari, you said?
So it was, Atari 64K. Yeah, that's
okay.
That's before the PC came in. So I got a PC as soon as it came out, but I started before that.
So what year would that be then? What year would that be?
I guess it was early 80s. I guess. Okay, so I studied computer science at the Israeli Institute of Technology, the Technion. I have a master's and bachelor's degree in computer science. So I love programming. I love computer science. I love software design. I enjoy.
It'll never catch on, Adam. It'll never catch on. It'll never catch on.
And basically to answer your question, how we came to invent visual testing, to basically create Applitools. So it all started, I think, about the seeds were about 15 years ago, an age ago, right? And back then I was running R&D for a security company in Israel. And just like a lot of security products, there's a lot of UI. You have policy definitions, and you have a lot of charts, and you have a lot of organizational structures where you assign policies to, and you have a lot of logging going on. So a lot of UI, and it was
it's quite complex and quite intense as a user experience. Yeah,
and it was localized or translated to 6 different languages, and it was white labeled 5 times. So it was like a big UI times 30.
Right, basically. Yeah. 6 languages times 5 different variants. Exactly. Yeah.
Exactly. So, and I was responsible for building this software and making sure that it works. I had a small army of about 25. I had an automation team. Even Selenium 1 was out back then, and we used it. And I had a small army of about 25 manual testers that used to check the UI and the whole user experience around that. And it would take about a full week for all these guys to do a single cycle of testing the entire UI of the product.
Oh, so you mean like if you think about 30 versions of the software you've got, and it took you a week to do one version? Is that right?
No, just to do the 30, all of them, cover everything, it would take them a full week.
Right, okay.
And back then, 15 years ago, it was like the Middle Ages of software development. It was the word DevOps.
At least you didn't say prehistoric then.
No, it's not prehistoric. That would be when I started programming. But no, back then it was like halfway, Middle Ages. The word DevOps didn't exist yet. We were building software in a waterfall type of project. We would plan a release for a full year. We would build a new release for a full year. And sometimes when we were late, it would take a year and a half to get that next build out. So we were talking about a completely different era in software development. And right about then, this new thing came along, which was agile software development. And everyone was talking about that and the benefits of frequent releases. The biggest challenge, by the way, back then was to convince the management that the company can actually survive releasing software like once a month, right? It was unheard of. It was like a miracle. And it did require a lot of changes, because if there's a marketing team that prepares for a full year to launch a product, all of a sudden they need to do it every month, it's a problem. It's a change for the whole business. So, of course, we, as an engineering team, we were very happy to do the most modern stuff, and we wanted to start doing agile development, and we convinced the business, and we started doing these faster releases and doing a retrospective at the end of every release and learning, the lessons from it and seeing how we can get better. But no matter what we did, we were stuck at 3 months. We couldn't get the release cycle any shorter. And every time we did a retrospective and try to figure out why did it take so long, the manual testing part of the UI was just always the reason. Because if it takes you a week to go through the whole thing, and then you find a bunch of bugs, and then you spend a week fixing them, and you do another week, and you find more bugs, and you spend a week fixing them, and then 4 days, and more days to fix, and 4 days, and then 2 days, and then...
Yeah, you keep going around this circle, don't you?
And so it's like a spiral, but at the end of the day, it's like a month and a half of testing and bug fixing. So you need another month and a half of development before that, and you get to 3 months. Okay, so we were stuck there. Now, as an R&D, VP R&D or engineering manager, it was my job to eliminate obstacles, to streamline the process. So I worked hard on finding a solution for this problem. And I looked for tools, a tool to buy. Open source, there was nothing open source then. Hardly any open source at all, except for Linux and maybe the Java programming language. But other than that, it wasn't so much available. But definitely there was no open source visual testing tool. And I went to speak with all the vendors of the time, big vendors. It was HP and Microsoft and IBM with their rational suite. And I spoke with all of them and tried to see if there's something that they can give me to automate testing the UI itself. I mean, Selenium allowed me to automate and test the functionality of the product through the UI. But it didn't allow me to test that the UI itself looks okay, that there are no typos, nothing breaks, or, in the layout of the UI, how things look like. And that was really missing there. And the annoying thing is that everyone kept telling me, this can't be done, automatically. This is a work for human beings, only they can do it. So after hearing that enough times, I decided to just go ahead and build this tool myself. Of course, I realized very quickly that it is much harder to do than what I expected, but it only encouraged me to continue and work on it. And eventually, this became Applitools today. After that company was acquired, basically the founder of that company, which is Gil, and myself and Moshe Milman, my third co-founder, we both worked already 8 years at that company. We joined forces and started Applitools and built the technology as it is today.
And what it's a great story. Thank you for sharing that. I mean, what do you? So for people that are listening on today's session, what's your definition of visual testing? What would you? Is it like taking a photograph of the UI and then having a before and after picture and doing the compare, or what would how?
So visual testing is basically the process. It needs to be supported by very strong technology, but the process itself of the way that you test. So visual testing basically means that you take a screenshot at a certain point in the execution of a test, and you compare it with a baseline image that defines how the application is expected to look like at this point in the test. If there are no differences between the two, nothing changed, okay, and the test passes. If there are differences, then the test will fail, and you have a way to observe the differences between the two, okay, and all you need to do is just decide whether to accept or reject the new image. If the difference is a valid change, a feature that was added you just added, you intentionally made this change, you accept the new screenshot, and it becomes a baseline image for subsequent test runs. If, on the other hand, it's a bug, you just reject it and report a bug. That's the workflow that you use. This is basically visual testing, okay? And the reason it doesn't exist is not because it's so difficult to think about this workflow. It's because it never worked, because comparing images is a very, very difficult task. And not only it needs to be done very accurately, it needs to scale. So we have, for example, customers today that are running hundreds of thousands of tests every day. Every day. So imagine the accuracy, hundreds of thousands of image comparison, and they should never see a bug. So it has to be close to perfect. 99% accurate is not good enough. Okay, that's thousands.
So you're looking right at the pixel level.
Yeah, so you cannot do it at the pixel level because it's not just that. But if we are talking about completely static screens where nothing changes and everything's supposed to look the same and there's no dynamic data, then we want to have exactly the same screenshot. It never happens that way for many reasons. First of all, a lot of the things that are drawn on the screen are drawn by the graphics card, by the operating system. And then it means that on my computer, when I run the test, I'll have different pixels than on yours, and definitely on the build machine. And if I have even if we have the same exact laptop, and my laptop is connected to a Retina screen, because that's how I like to work, the pixels are different. And if I have a different driver version, the pixels are different. But just to understand why, so every image you have on your web page, for example, is it's not necessarily at the same size of the source file that defines this image. So usually you scale it to some proportions that you want to have on the screen. The scaling algorithm is not implemented in the browser or something like that. It's implemented by the graphics card. So every graphics card produces different pixels. Every letter that you have on screen, every diagonal line has anti-aliasing pixels on it to make, so because the pixels are square, it allows to smooth those diagonal lines so you don't see the square shapes of the pixels. So the algorithm that adds these anti-aliasing pixels is not uniform and it's not universal. Every device would implement it in a different way, and the number of pixels that you have on screen also affects the algorithm. So you constantly have these variations. And if you think of a web page, anyone that builds websites knows that you're not saying put this text box exactly at this pixel. There's a layout manager for the browser, and it determines when to put it. Now it can decide to put it 1 pixel below or half a pixel below for its own reasons, and then everything shifts. If you're just comparing a pixel to a pixel, there could be 80% difference on the page, but you cannot see it.
I mean, that's why I asked the question, because it's a level of granularity that you're doing to compare out the differences, I suppose, isn't it?
Yeah. So basically, the idea is to be able to alert on anything that is visible to the human eye, such as a comma changing to a period, which could be just 2 pixels out of tens of millions, or plus symbol changing to a minus, which is of course very important and can be just 4 pixel difference out of tens of millions. But then if if the browser decides to shift an entire div downwards and that causes 80% of the pixels to be different, we cannot see it, we don't care about it, so we never alert on it. And all this work is just to deal with static pages. Imagine something like Amazon product page where you have new products coming in and out depending on what you have on the inventory and what you're trying to promote, and the deal of the day and advertisement and all this dynamic action
content,
on the page.
Dynamic content, yeah.
There's no problem for you to tell a manual tester, look, my friend, this is how the page should look like. Pay attention to, there should be products aligned to the left. If there are more than that, it's a row below. Pay attention to the pricing, to the description, to all this stuff. Don't worry if there is an advertisement here, it's okay. And now the guy can look at the page all day. And if there's one more product, one less product, he won't open a bug, right? If something goes wrong on the page, all of a sudden products disappear. There's no image, the description is missing, you know, products overlap, he will raise a bug. So we have algorithms that can do that, okay? So we can just show them few baseline images, they understand the pattern, and they can apply it in production with very high accuracy. And then there are plenty of other algorithmic work that can be done, comparing a screenshot from one device to another device in a different form factor, automatically doing maintenance for you. So for example, if there's a change that occurs many, many times across your application or different devices and browsers, it's enough to just look at it and approve or reject it once. You have an AI that goes and does that for you everywhere else, so you don't need to approve or reject the same difference like 1,000 times. So there's plenty of algorithmic work, and basically this is what we do at Applitools. It's a computer vision company. We have a big team that for more than 10 years is refining and improving these algorithms, and it's a lot of fun.
I'm sure it is. So in terms of the impact of the innovation that you built, what do you see today? What are the kind of examples of, you know, people before they embrace this type of technology and this type of approach, and what's the situation now? What's the before and after kind of business impact, technology impact? Any view on that?
Yeah, so it's the impact is huge. So first of all, before Applitools and after Applitools, you know, visual testing didn't exist. Today, if you search for visual testing, you'll find maybe 30 open source projects and some vendors that are offering this. So it is a new category in testing that is very useful. Another thing that changed during the lifetime of the company is that 10 years ago, the user interface, the UI, was the least important interface of any system. You can probably remember that even if you had a bug in your application and you would report it, the support guys would explain to you how to work around it, and they would say maybe in the next release in a year we'll fix it for you, but it wasn't considered important. As long as you can use it somehow, it was okay. And today, the user interface is the most important interface of any system. We might argue that if the end user cannot see the bug, it doesn't exist. Right, and every company in the world, it doesn't matter what it does, the main way, it's a software company, like the main way in which it interacts with customers is through websites and applications. So really, the user interface is the most important interface. And the fact that you can now automatically test it is priceless. I mean, it was impossible to work without it. Now, not all teams use visual testing solutions. They should. I mean, there's really no absolutely.
I wouldn't expect any other answer to that. They should.
They should, because there is absolutely no reason not to. It's not that you need to do it manually more. It's not that the UI is less important. It's not that you don't have bugs in the UI. All of these things matter. There is a solution to. There are plenty of solutions to use it. So it's really, you know, this part of the profession. We need to test. Front-end developers build front ends. You need to test front ends, and there are tools that can do it very well today. Now, beyond the visual coverage, And also, I mean, another aspect of it is that software engineering has evolved. We now do continuous deployment, continuous delivery. Teams are releasing software several times a day, not once 3 months.
Yeah, the cycle times collapsed, doesn't it? The cycle times collapsed. Yeah.
Speed is critical here. Okay, speed. These are business critical applications. Speed is critical. Quality is critical. So it's not really an option today to test manually anymore. Whoever is testing manually is taking a lot of risks. Okay, they are doing a big compromise, or they are just releasing slow, because you cannot test something. The UI is very sensitive to the form factor of the device. Not all browsers show exactly the same UI giving the same code, the same HTML and CSS, etc. So you need to test across a wide range of devices and browsers, and you cannot do it really manually anymore. Okay, so
yeah, so it's more. So it's kind of like it's the evolution has been that there's more customer-facing applications, there's more complexity in those applications, and the speed of or the requirement from the business is to release more often. So you can, if you put all those things together, it means there's more complexity, there's more, so you could say, pressure on that testing function to be more strategic and also more productive.
Yeah,
not be a bottleneck.
Exactly. And again, one way is not to test, so you don't have a bottleneck, but you sacrifice big risk with quality.
Yeah, unless you want like a meltdown in support or something like that. Yeah.
Yeah, but of course it's better. There are tools that allow you to automate all of that and release fast without taking risks. So that's important. Now, beyond visual testing, the one thing that is very interesting is that this approach, the visual testing approach, has proven to be extremely effective for functional testing as well in general. When think of it, the simplest way to think of it, if you have a calculator and you've done 1 + 1, it came out as a 3. That's a functional bug.
Yeah.
But because a 3 doesn't look like a 2, a visual testing tool would flag it. So it's not just limited to, does the output have the right color, shape, size, the correct position? Nothing's hiding it. It's also the functionality that is exposed in the UI. So this type of testing does cover functionality as well, but it has a lot of advantages. First of all, a single line of code that covers the entire screen replaces thousands of lines of code that you would otherwise have to write, right? So it's a lot more coverage. Everything that is there on the screen gets covered. It finds unexpected issues, not just if the specific assertions that you've written down, the 3 assertions on this big page break, you get a test failing. Any difference that your end user sees, you will be alerted and you will know about it. It adds the coverage that you wouldn't otherwise implement in your test anyway, but it also includes coverage for all the assertions that you used to write before. So what we see, for example, with our customers, and we have hundreds of them, is that the code base, the test code base becomes 80% smaller. So it's 80% less code to write when you create a test, but more importantly, 80% less code to write when to maintain during the lifetime of the test, which is crucial. And the last part of it is that maintaining a test like that, a visual test, only requires you to click a button to accept or reject. It means that everyone in the team that knows the product can do this. It means that you don't need the developers to spend time maintaining the automated test. It means that everyone in the team, manual tester, product designer,
business analysts,
business analysts, all of them together can maintain the automated tests. So this really opens up a huge bottleneck that teams have with their automation period, not just visual testing, with their test automation period, by reducing the amount of code by 80%, massively increasing the coverage that they get out of automation, and having much more manpower to maintain the test, freeing up the developers to write less code and continue add more tests and keep up with the coverage of the application without being bothered by constantly, maintaining the tests, handling flakiness, fixing test code when the UI changes, etc. So it's a real game changer for companies. Basically, a lot of our customers today use the product not to get visual test coverage, but actually to succeed with automation. To
Right.
automate okay, so that's the value proposition. When you are basing your tests on this technology, you can also speed up the execution of tests, because basically, if you want to test on different devices and browsers, one of the technologies, the ultra-fast grid that we have invented at Applitools as well, is the ability to look at a single run on one browser or device, okay? And when you do a checkpoint on that one run, we have the technology that can extract all the resources from that browser or device and replicate it on different browsers and devices, and immediately show you the UI as it was running, as it would have been shown on these different devices. On
the different variants of device,
exactly.
like on Edge or...
Exactly. And then we can
Chrome,
screenshot all of these in parallel and compare them with their baseline. So let's say you have 1,000 tests and you want to test on 20 different devices and browsers. Instead of running 20,000 tests, that is running that test on 20 different devices and browsers from beginning to end, which everyone here that is aware of the downsides of this approach. You can still run the 1,000 tests locally on a dev machine, on a build machine. Doesn't matter which browser, the easiest and cheapest one for you to do. That's enough to get the coverage on all the different devices and browsers. Okay, so it's like you can even run your test suite 100 times faster without the security concerns, flakiness, and all of that. So there's plenty of upsides to this approach. Yeah, so that made a big difference in the testing industry.
I mean, in terms of, so I mean, there's a great narrative there. I mean, I suppose the question for me would be, have you seen a difference in, I mean, obviously we had this kind of situation a few years ago with the pandemic where, people were having to change their working patterns but presume people were still developing software. So have you seen a difference between pre-COVID, during COVID, and post-COVID of the approach to testing and automation? Any perspectives on that?
Yeah, so I think that what I described about businesses using applications and website to communicate with their customers is what we call the digital transformation. This is the, let's say, the marketing buzzword to describe this phenomenon.
The hook. Yeah.
This is a process that started a few years before COVID. But when COVID hit, it became, no one left the house, right? No one would actually go to an address to speak with anyone. So that was the only way to do business. And that really boosted up, this whole process, and teams everywhere were like, this whole process was on steroids. Right.
Oh, really?
So there was a lot of applications being built everywhere, a lot of digitalization, and also because people were not coming to the office, working from home. There was a lot of pressure to automate stuff, and not rely on people like coming in and sitting together and working together. And that was a very good time business-wise to companies such as Applitools.
It accelerated people embracing this approach because they saw it as more of a critical part of their digital transformation.
Yeah, and also, I mean, side by side to that, there was a lot of money available. So money was cheap. Everyone had money. A lot of companies raised a lot of money. There was a boom in recruiting. It wasn't so long ago. It was very difficult to even find people to hire. A big competition on everyone that you can hire, and companies grew. And this means more people testing, more applications being developed.
Yeah.
So that was, I think, a very good age for, software shops, engineering teams, and software engineering in general.
So we call it the COVID Renaissance. So what have you seen? Have you seen any change in that since the COVID?
Yeah. So of course,
got back to normal, you could say.
It's not. I don't think that post-COVID changed anything. I think that the world economics have changed recently. So we are seeing this big companies firing, tens of thousands of people. Everyone is on the job market is now find it harder to find a job. You can feel it. As part of this, what I can see is, sometimes some projects that weren't so lucrative are being shut down. Some, companies are much more aware of their spend, focusing on saving money, investing in things that make money or help them save money and become more efficient. In general, automating stuff makes you more efficient, so that's a good thing. Mm-hmm. So there is still a pressure and need around that. But yes, it's different. I mean, you can definitely feel that, everyone is thinking twice about the money they spend and how they spend it. And to justify it, it requires more work.
Exactly. Yeah. Well, I mean, I suppose it's going back to the kind of classic thing about you got to have a payback on this thing, but it sounds like, automation is not going anywhere. The kind of key capability you built with visual testing, there's some big productivity gains from actually embracing it. So, and also I suppose it makes people less fearful of building bigger and more complex applications, because it's a bit like something to help you actually get through that stage of the application. Because, one of my friends at Expedia says, testing is never sexy. Yeah.
Yeah.
So, it's like, it's I think if we use the phrase necessary evil. So if you can try and make it as pleasant as possible, then that's a great thing to do, isn't it? So I'm just aware we've been running for about half an hour now. So anybody in the actual in the group, some questions from the audience. If you wanted to start, anybody got any questions or want to come up on stage and ask Adam any questions, please let us know and raise your hand. I think there should be a raise hand button at the bottom of your screens, and also you can put some open questions into the Q&A section, which should be at the bottom of your screens as well. So please let us know. We'll wait for you to submit some questions, and then we'll continue until you've got something, people that want to come up on stage and interact live with Adam and myself. So one of the things I was going to ask you about was in terms of I suppose touching on a bit about the future. I noticed actually, because I just got an email the other day, there's some kind of new capability that you've just released. It's called Centra. Is that right? Yeah.
So Centra is by the way, an awesome free tool. It's free. It will be free forever. It's not actually so much as a testing tool. It's more of a tool that we've built to address the friction between designers and front-end engineers. Mm-hmm. We see that, although there are plenty of tools that help come up with a concept for a design, like Sketch, or do the design itself, like Figma.
Right, okay, like Figma, yeah.
Other tools. There is no tool that actually tracks the process of handing over a design to developers and then reviewing or documenting or collaborating around the different versions of the implementation for that design versus the versions of the design itself as it evolves. As everyone who is involved in software engineering, that it's like the process is fitting itself. And there's a lot of sometimes confusion and friction around it. So for example, I see cases where a developer finishes the implementation, but it's difficult for him to show the designer that he did that. So, the designer has to wait 2 weeks until the sprints to be over to see that and comment on that and give feedback. And it's a shame. Or I see cases where the developer finishes the implementation, presents it, and then the designer will tell him, hey, we changed this design last week. You just built the wrong design, which is super annoying. How can the designer tell that there is a new implementation version? How can the developer know that there is a new design version? Right. How can we see the historical version of the design? Okay, I got a new design. What's changed? Who knows? Right? This is a new design. Where can I focus?
So you're trying to create some more better, easy ways collaboration across the roles. Yeah.
Yeah. So it's a great tool. It's like hooked into Figma, your Figma project. Whenever the designer updates a frame, basically when he synchronizes a center with the Figma project, immediately everything that's changed is marked as such. The developers get an email notifying them that there's an update on the frames that updates. They click a button, they immediately see the new design. They can then implement it, just take a screenshot, paste it next to it, and then the designer gets an email that tells him, oh, there's a new implementation. And then they can collaborate just like Google Docs comments. They can collaborate, and the designer can actually decide to approve or reject the new implementation. So now it's documented as part of the project. No one can say that it wasn't.
You got you got traceability there as well.
Exactly. So you basically have a complete way to track everything that happened, see the historical versions, compare the new implementation with the previous one, the design with the previous design, and just see who approved, when did they approve, what was the feedback that was given to that led to certain changes, either in the implementation or the design. So it's a fantastic tool. We're using it internally, and it's now open for everyone to use, and it's free. Okay, so that's just a nice tool that we have.
Nice. I've got a question from the audience actually. It's actually from an anonymous attendee. So you're obviously I don't know if this is interesting rather than declaring who the person is. But anyway, so saying so this is to Adam. What are your thoughts on record and playback tools, e.g., like Selenium IDE or similar, either open source or commercial? Do you think they are the future of testing? If not, what will replace it? Yeah.
So record and playback tools have been around forever. I mean, the first test automation tool, WinRunner, was a record and playback tool. Okay, so actually, as you know, it was created by, maybe you don't know, but it was created by an Israeli company called Mercury that basically
Mercury Interactive, wasn't it?
Test automation. And the Selenium project, Selenium is still here, alive and kicking. Is basically Selenium is a cure to mercury poisoning. This is why this project was. This is how it was named. And the reason is that it took a different perspective. It said, no, you cannot succeed with record playback. You need developers to write code. So we'll call it Selenium, and it ushered a new era where test automation was written in code. But then again, after a decade or so, new companies came up, modern companies that did again what WinRunner did 20 years ago with a nicer UX and maybe some small improvements, but based on the same concept and ideas. So I'll tell you what I think about record playback. I think that teams today in general don't succeed with test automation. It's very difficult still. If it's developers writing code, the more tests you write, the more maintenance you have to do. At some point, you spend more time maintaining than writing more tests, and you get stuck. There's a glass ceiling. There are two ways basically to overcome this glass ceiling. First of all, add more people that can work on automation. And since you cannot recruit an endless number of developers to write tests, first of all, because it's expensive. Second, because there are not enough practitioners available to do that. The obvious way is to include more people that don't necessarily know how to code, and this gets you to record playback tools that lower the bar and allow more people to participate in authoring tests and maintaining them. Okay. The second way people are trying to break this glass ceiling is to look at AI. And basically they're looking for a smart solution that will reduce the amount of maintenance that can be done. And one of the most effective techniques that are available today is self-healing. Okay, basically, what is self-healing? It's a simple concept. Basically, every step in a test today involves locating an element in the UI and interacting. Every step. Either you're finding it to click it or do some interaction with it, or you're finding it to get its properties and assert on them. Unless you're doing visual testing, in which case you just check the whole page and you don't care about the individual elements. But still, even for interaction code, you have to do it. Okay, you have to find elements. The problem, the majority of maintenance involved in testing happens when the UI changes. And then the element locators that you have that actually find those elements for you no longer work. Then the test fails and you have to spend a lot of time figuring out what went wrong and then spending a developer's time on fixing the test and updating the locators, right? So self-healing allows the test to still continue to run even when the UI changed and the locator that you're using is no longer relevant. How does that happen? Basically, the system that executes your tests, the infrastructure that executes the test, every time you're trying to find an element, when it finds the element, it builds a database of information on that element, includes all the properties known on that element, its position in the hierarchy, the elements surrounding it, and it stores this information in a database, and the key to access the information is the original locator that you've used. Now, when the UI changes and the locator no longer works, instead of just telling you, I cannot find the element, you take the locator, you go to the database, there's a wealth of information there about this element, and then you apply your own algorithms to find the element by the tool that the infrastructure does that. Okay, so once it finds it, it returns it, and basically your test doesn't crash. You still get access to the element, although the locator is no longer relevant. Now, it happens to be that the modern record playback companies are offering this as a premium feature that is built into their applications, into their closed systems. Now, until today, it was only available there. So as a record playback company, I could promise you, look, you can have everyone in the team, not just the developers, author test, but as a bonus, you'll also get self-healing. But the downside is that you have to throw away all the tests that you've implemented before. Now you have to build everything on my system, and you're locked there forever because you cannot go away. You're writing tests in a tool that is closed, and you can only use this on my system, right? And usually developers don't like to be told what to work with, and so that's a downside to using this approach. So I do think that by lowering the bar for the people that can contribute to automation, plus the benefits of self-healing, is an appealing attraction and something positive towards record playback. On the other hand, it goes without saying that when you lower the bar, you have less qualified people authoring tests. Naturally, they will do not as good as a job as if it was a software engineer who is experienced in writing software projects, right? And because of that, maybe there are challenges with those tests, right? If you would have had a very good developer writing those tests, you would be in a better state, a more stable or fast or effective test framework. So it's a balance, but even with just expert developers, still companies struggle with test automation. So it's not like just writing test with code works 100%. No, it's still difficult. There are still challenges, and these tools are a real viable alternative. Now, Applitools is now, next month actually, we are releasing the first self-healing test execution cloud. It means that if you're running your test on our devices and browsers, you're getting self-healing for free without needing to change your test. So if you have a Selenium test, for example, you have 1,000 Selenium tests, you don't need to change a line of code. All you need to do is open a remote WebDriver, run it on our devices, and you get self-healing. Okay, so that's a new thing that I'm super excited about. And
is this like a little reveal? Is this like an exclusive we've got?
Is an exclusive and a reveal, yeah. We'll have a webinar. We'll have a webinar next month.
You should have told me about that. I could have like got like the disco balls and the kind of the dry ice hat got running. You just gonna snuck that in.
Whoever is here has got a glimpse into the future. We'll have a webinar on that next month, and we'll demonstrate the tool in action and everything. So, yeah, this is, I think, is a very important addition. Something that didn't exist before as an option, but self-healing is going to be something that everyone can use today.
So it's like bringing self-healing to the masses, basically.
Yeah, exactly.
A kind of cloud scale.
Yeah, and without vendor lock-in and without having to rewrite everything from scratch on a different system. And why
have you done that? Why have you done that?
Because it makes sense and it gives value to our customers.
Okay. Okay.
And
was the trigger for that? Was that the trigger for that from the customers asking for that next evolution?
So look,
or was it a bit of both? Was it you seeing what you were doing and also them giving you feedback? Or was it a combination?
So first of all, Applitools has always been an innovative company. We never ever did something that was like what others do. We're always looking for the fresh way to advance the field of software engineering in general. So visual testing was a new thing. The ultra-fast grid was a new thing. Now self-healing for execution cloud. Execution clouds have been around for 15 years. Okay, one of the vendors, I won't tell, I was in their advisory board way back before we even had a test infrastructure. We were just visual testing. And I told them 7 years ago, hey, you can do self-healing as part of your infrastructure. They didn't like it for some reason. They didn't want to do it, but it makes a lot of sense, right?
Yeah.
So now we are doing it. But the anonymous guy asked me if record playback is the future. The future is not record playback. The future is autonomous. Okay, the future, just like self-driving vehicles, the future is AI that is testing your product for you, getting you to 80% coverage or more without you having to do anything.
So,
just providing very few hints.
So, quick question, is that, so you saying that it then explores, discovers the application, generates the tests, and then executes the test and then gives you the results? Is that what you say as being the life cycle?
Yep. So there are many ways to accomplish that. There are many ways to accomplish that, not necessarily according to the pattern that you mentioned. So for example, if you recall what I said about ultra-fast grid, where I can just capture the state of the UI and replicate it on as many browsers and devices that I want and then test it. So just to give you an idea, we have all the technology that's needed today to give you a snippet of HTML that you put in your website or your web application. And then when your customers are visiting your application, whenever they get to a page that wasn't tested for an hour, 2, a day, whatever you decide, we can actually give you the coverage for that page and tell you if something is broken. So you don't even need to create a test and maintain it and run it just by the traffic that's going on by your real users visiting pages. They are getting to
I
pages.
see. I
We
see.
can
Okay.
validate it. So I'm just saying the pattern that you are describing is a valid option to do it, but there are other ways to get to it, and it's well within our reach.
So it's like, so what you're saying is like intelligent test selection.
Yeah. Or let's look at it in a different way. Let's say that you can think of, it's impossible to test all the applications in the world, right? It's difficult, probably impossible task, but you don't have to do it. Let's say that you build an AI that have seen 100 different banking apps.
Mm-hmm.
There are thousands of banks, tens of thousands of banking apps, if not more than that. Every team is rebuilding those apps and rewriting test suites for it. But it's quite easy to teach AI how a banking app should look like. And when it sees a new one, it can figure out how the same concepts are mapped on that app. And then once it does that, it can immediately speed out a very robust and complete test suite for banking apps, because they all do the same thing on purpose, right? We're supposed to be, as customers, it should be easy for us to use them. Mm-hmm. Right? So, and it would just save you the trouble of writing a test suite if you're working for a bank. And there are so many banks and probably millions of developers working at banks around the world. So that's a big deal. And if you do it for banking, you can do it for retail applications. Guess what? Everyone has products with a picture of a product and a description and a rating and a price and an inventory and all of that. So it's very easy to address and build autonomous system that way. Mm-hmm. So this year we will have the world's first autonomous product. I won't get into the details of that. This is a later announcement.
This is a tease. It's a tease.
It's a tease, exactly. But yeah, this is where we're going for. And given that AI will never give you 100% coverage, first of all, it's okay because anyone that is automating today end-to-end is hardly getting to 20% coverage, no more than that. So even if it gets to 80, 90%, that's huge. And you don't need to do anything. But for the remaining 10%, there are ways to give hints. The thing would be to give hints to the AI. Okay, and similarly to how visual AI works today, I don't believe that AI will ever be able to detect bugs and declare that something is a bug just because I see people not disagreeing on what a bug is. The developer likes it, the product doesn't like it, they argue about it, they need to go to the manager to decide if this needs to be fixed, low priority, high priority. If people can decide, machines won't be able to decide.
Yeah, you've got to have some human oversight. Yeah, exactly.
But you will have human interaction that will need to give feedback. This is okay, this is not okay. But you won't have to write and maintain the tests. You just need to respond to findings. Okay, so this is the future. And it's, believe me, we are 6 months away from it. Okay, so it's right around the corner.
Well, it sounds like we've got some exciting things coming up. So you said that the little announcement that was that you saying what next month in April or May?
In April, yeah, in April we are launching the self-healing, the world's first self-healing execution cloud, and autonomous testing is just around the corner. I hope you release it second half of this year.
Well, I hope you're releasing it on my birthday, because my birthday is the 28th of April. So I hope we'll have to make sure you launch it on that day.
Let me talk with my head of product, maybe.
So, I mean, in terms of any other things, I mean, obviously you said some big things about self-healing. You said about actually leveraging the autonomy, the kind of the autonomous. And so, I mean, just to clarify that was kind of like you coming up with the idea or seeing the opportunity, but also, were you seeing the maturity in the customers as well, where they were having to get to that stage where they needed that capability? Was it a gap that you felt you had to plug? Was it something that was like a next part of their journey?
It was very clear. It's very clear. Customers, I speak with, we have a lot of big customers. One of the challenges that they have is that they actually pay for tools And it's hard for them to even convince the teams to use them because teams are overworked. They have a lot of deadlines. They have a lot of responsibility, and they just don't have the time to pick up testing. Companies want to shift left. Teams, in most cases, don't want to shift left. They don't want to take on additional responsibility. Actually, we see customers saying, help us get teams to use the tool. It's excellent. We have many teams succeeding with it. Other teams, I mean, how can we get them? Help us. What can we tell them to convince them to do it? Okay, so it's just that teams just don't have time to invest in testing and make it successful. Okay, so with autonomous, basically this pain goes away because right from the start, you're not starting with writing the first test or writing the second test. You're starting with 80% coverage.
Yeah.
Okay, and this is a real need. The second real need is even the teams that do invest in automation don't succeed. Okay, and this will solve that. Okay, so this is why it's giving
you a big leg up basically from day one.
Yeah,
because it sounds like you said what you said is one of the challenges is the adoption. They never have enough. You know, they're trying to get time back from testing to improve, but then they don't have time to implement to get the productivity gap back. It's like a kind of vicious circle.
Yeah, yeah. You can use the best framework ever. If you're not using it, you're not seeing the value, right?
So it sounds like you've got to continue to evangelize and also explain the benefits of adoption. It sounds like it's a people thing, isn't it? It's a win in the hearts and minds kind of thing.
I think that it gets better all the time because companies understand quality, developers understand quality. Developers test today much more than they have before. That takes its time. But with autonomous testing, the question goes away because you don't need to invest anymore. You get much more coverage. So I think this is the leap forward, getting quality without having to invest so much in quality.
It's like a quantum leap. Yeah,
exactly.
I was actually going to write a book actually a few years ago, which I never got around to doing, which was going to be, like men are from Venus and, women are from Mars, or the other way around. Like software developers are from Venus and testers are from Mars. But
I think the borders are slightly.
But they kind of it's getting more grey now as they kind of realize the value from both sides. There's not a hierarchy. Yeah,
exactly.
I can say that obviously because I'm a co-organizer of a testing community. See, so I'm allowed to say that. Fantastic. Well, I'm just checking. There is, if anybody else has any more final questions from the audience, but I think we're going to wrap up with just, I suppose, maybe just to say a big thank you, really, for you, Adam, for joining us today and sharing all those value bombs, as I would call them, dropping all those value bombs on the community, and just to say that next time when you're over, what we'll do is we'll actually do it in person. We'll get a facility in central London, which is what we used to do. We've had some very big sessions over the last few years where we had 150, 200 people in London. This is obviously before COVID. So I think some people have actually, it's that thing about what do you do as an option? Because I think people have got used to being online. And then how do you do this thing about, how do you have a hybrid kind of thing? But I think the key to it actually is to have more swag. Yeah. So you need to be.
So if we do it, face to face, we can get some swag, and that would be great.
And then obviously
thank you for having me, Andrew.
Well, yeah, it's usually swag, pizza, and beer. That's probably that's the dangerous combination. It's not very healthy, but maybe it's and obviously if you eat too much pizza and drink too much beer, then you can't fit in the t-shirts. But maybe you have to get a bigger size. But no, of course, yeah. I mean, thank you for coming on today's event and sharing your experience and your knowledge with the community. And obviously, what we'll be doing is we'll put this up on our YouTube channel as well that we've got, which has got a multitude of, and obviously we can then share little snippets. And we should finish off without both of our glasses on. You see, shouldn't we? Really? I mean, You know, this is Adam Schwarzenegger, Carmi and Andrew Turner.
I can't see anything.
You
It's
can't
like
see anything.
Adam and Stevie Wonder. I feel like
Stevie Wonder. The Israeli Stevie Wonder, exactly.
Exactly.
Thank you very much for coming on the show tonight and the event tonight, and very much appreciated. And thanks for all the audience turning up today, and thanks for asking the questions. And that's been Andrew Turner, the co-organizer of London TAD, and that's been Adam Carmi, who's the co-founder and CTO of Applitools. So have a wonderful evening, everybody, and I know you're going to enjoy yourself afterwards, so enjoy yourself later as well.
Thank you. You too.
Take care.
Bye-bye.
Bye-bye.